Thank you so much, Alex. And yeah, thank you. It's a very good introduction because it's exactly what I'm going to talk about. And I'm really happy to be starting this session on online and offline testing with children, because I think there's so much going on right now in the developmental world trying to get our research back up and running. So let me tell you a little bit about the background to what I'm going to talk about and about our movement online. So the original idea was investigating the effect of a noisy home environment on the development of attention in infants. This required a lot of lab and in-home research, eye tracking, behavioral measures, sound monitoring home, sleep monitoring, several visits. And this is the work of Brittany Scher, who's my current PhD student, and also Julia Serino, who's a research intern and soon to be PhD student with us. We ran 49 infants, 2 sessions each. We got about a third to a half of the way of the number needed, and then face-to-face testing was stopped. And we decided to sit back and think about what we were going to do next. And we wanted to consider how best to use our research given the current situation. So we studied the environment and how the environment affects attention, how it affects learning, and that's what we've been doing for a number of years. And the environment has changed in 2 very specific ways for us as researchers and for the children. So as we know, and if you've been listening to the talks going on all day, people have talked a lot about how in the lab we can control most variables. We control light levels, sound levels, number of people in the space, size of the space when we test, et cetera, et cetera. And that is a lot harder to do. And we've had to come up with some kind of interesting sort of cheats around that. However, one thing I think we also need to be mindful of is how the change in the environment is not just affecting how we're testing, but it's affecting what our data is. It's affecting child development. So we've got kids who are at home right now. There could be crowding in their house, lack of socializing, lack of engagement with their work with other people. There could be stuff going on emotionally. There could be a lack of outdoor space, and there is a lot of noise. And this is something that we are interested in. So these are our challenges. One is the challenge of testing online without being able to control the environment. And the second is considering the impact of the environment on the actual performance. And I think this is a bigger and more long-term issue. We have done such a good job historically of removing the environment and creating really clean data so that we can really understand how the brain develops, how behavior changes. But as we all know, development occurs in the middle of everything. And so I think it's very interesting to consider how our data is changing based on the physical and emotional environment during COVID and how we can quantify that. So we have some potential solutions. We can use online platforms to offer some form of control. We can give instructions to parents about where testing should occur, when it should occur. We can use GDPR-approved conferencing platforms, video platforms to observe the environment. We can talk to the parents. We can talk to the kids. We can make, eye-to-eye contact with the babies if we're testing babies. We can chat to the teenagers and the other children. And we can get parents involved as proxy researchers. I had the pleasure of seeing a poster by Elena Throm during the poster session at lunchtime. And if you have a chance to go and look at it after this, please do. It was very, very interesting talking about how they're actually getting parents to use an app to actually run a study seeing how babies are reacting to particular sounds. It's really, really slick. You can see the home, if that's something that is important to you to see the research setting. There's some ethical implications there, but it's something you could consider. And you also need to make sure you're asking the appropriate questions about the environment and see how you can potentially measure them. All right, so I'm going to give you an example based on the work we're doing. This is preliminary data, and this is a preliminary, we just started this study, but this is what we're doing. So we're thinking about how the current environment is affecting home learning. We have decided to look at secondary school students who are under a great deal of pressure right now. We have these kids who are feeling academic pressure, they're teenagers, there's everything that's going on that's about being a teenager, and now there's all this other stuff happening. So we decided to look at some executive functions, inhibitory control, memory, and cognitive flexibility, and there's 2 conditions, which I'll come back to in a bit, home noise and white noise. As an aside, I did a little Google image search to find pictures of kids home learning, and those were the first 3 pictures that come out. And I practically wept looking at them because, first of all, look how tidy their little homes are and how clean they are, how clean the children are. And this like one parent to one child kind of thing. And the kids are engaged and they look like they showered that morning. And I just thought, no. So I went upstairs and took a picture of what I saw when I got up. These are my kids. We've got Spotify going on, one kid on YouTube, I think watching anime, the other with her guitar, and my son doing his Spanish homework in the middle of it. And what you can't hear is the noise of the Zoom call my husband is on in the background, or the construction happening in the house backing onto ours. And there is no one-on-one parent-child interaction. So there's a lot of variability in how kids are dealing with this situation. And I've got two giggling right there and they have to stop. So the first thing we needed to do here was to get online. We used the Gorilla platform, huzzah. It's incredibly easy to use and did exactly what we wanted it to do. We were interested in noise, as I said, so we needed the participants to do sound level checks. Now, usually we would be there with them. We've got these really fancy sound level monitors they can have in their homes that we can send them home after lab visits, or we'd be in classrooms and we can measure it. Obviously, we couldn't do that. We couldn't really afford to send monitors to every single, anyway, you can imagine. It's a lot to try and get the participants to do that. So we had to think about how we were going to get around that. And what we decided to do is, instead of having an objective measure of the decibel level, was that we'd make it more of a phenomenological experience. And so in Gorilla, what they have to do is listen to a tone and they have to play it a number of times until and adjust their volume until they get to a point where it's loud but not upsetting. These are teenagers, so we thought this was okay. We have a parent guardian check. And then we had a headphone check to make sure their headphones were actually working, because they need to be wearing them during the task. And what that did was, although it's not as controlled as we'd like it to be, there was sort of this phenomenological element of this is loud and it is interfering to some degree. We then measured the environment, and we had some subjective questions for the parents to answer, some questionnaires for the parents and the children to answer, and then some just for the children. All around, there were socio-demographic questions, and then questions around what the noise situation is like in their household, and questions for the kids to actually say whether they're annoyed about the noise or what they can hear in their home environment, just to get a sense of how this might be correlating with their performance. These are tasks that we were already on Gorilla, so we just needed to plug them in. We have the flanker task, which measures inhibitory control. You just need to indicate the direction of the middle arrow. If it's congruent, you're quite fast. If it's incongruent, you're less fast. That's the flanker effect. Wisconsin card sorting task is a rule generation task, and it looks at cognitive flexibility. And then there's backwards digit span, which is kind of does what it says on the tin. It measures your digit span. You get a couple of numbers come up and then you have to key them in backwards, and you go on with increasing list size until you can't do it anymore. And it happens in one of two conditions. So there was home noise, which you can hear. That's home noise. No language, because we don't know what language they're speaking, but sort of generalized kitchen nonsense and a little bit of alien PS4 situation in the background. I think there's a Hoover that goes on at some point. And this plays through all three tasks. Or there was white noise, which is white noise. All right. So I'm going to tell you some preliminary results. What we found with our 15 subjects is that they performed worse on all three of our tasks in the home noise condition than in the white noise condition. And it's already starting to be something that looks as if we can trust it, this finding. And the most interesting one was the flanker reaction time. So what we see when we take it apart is that you see a flanker effect during home noise and almost not really one at all during the white noise. So we obviously, this is the beginning, we need to peel this back and see what the direction is, if there's the home noise is dragging it down or if the white noise is dragging it up, but we're going to go into that, but we're already starting to see some differences in performance. I had a quick peek around to look at the questionnaires, and I picked this one. There are more than one sound devices on in my home at any given time. And what we see again is that if you have said that's very much like my house, you show a nice big flanker effect, which suggests, you know, a big difference between congruent and incongruent. So you're much faster and congruent than incongruent. And by the time you get down to not at all like my house, then you're no longer seeing that effect, which is the beginning of something. And it looks like it's going to interact with what condition you're in. So we're starting to see some stuff here that is going to look kind of interesting. Beginning, obviously everything's the beginning right now. But what I really want to press home, and what is my major conclusion, is that the environment is incredibly important. We really need to consider not only how we control the environment in our online studies, but we also have to really think about how the environment is affecting development and what we are actually getting when we're getting the data. So if we're going online and doing eye tracking or looking time or reaction time, what exactly can we say about this data when it comes out? And how have we at least measured what the environment is that these kids are in while we're doing this? So that's sort of my take-home message. And here are some kids learning in a variety of different ways from my friends. And I would like to say thank you very much to my wonderful lab, the CBCD, along with Brittany and Julia, of course, and Leslie and Denis, who run the CBCD.